So tell me what this one's called, please. Any ideas? So it looks like a root, right? What kind of root does it look like? A square root? Guess what it's called? However, it does have another name, so I'm going to write both of them. Square root's the one you're most familiar with, right? Guys, this symbol right here is actually called a radical. What we do with it is we take a square root. Okay, but the symbol is actually called a radical, so I want to make sure you have both of those written down. Okay, so let's pick some values for our table, keeping in mind the things that we talked about yesterday about choosing smart values for our table, right? So what kind of x values do you think we want to choose in this particular problem? We want to choose something that's squared so that when we take the square root of it, like it's something we know, right? That makes sense, doesn't it? Okay, so what numbers do you know the square root of? 9. What is the square root of 9? 3. Okay, what else do you know the square root of? 4. What's the square root of 4? 2. Now, do you know the square root of 16? Yeah, that's 4, right? But why is that a poor choice? Exactly. It's a fine choice for our table, but it doesn't fit on our graph, so we would do better choosing a different value. Okay? What about, can I put that down here and we'll talk about it in a minute? What about 1? Do you know the square root of 1? Like what times itself is 1? Oh, 1. Okay. And what's another value that we always like to choose? 0. Okay. What times itself equals 0? 0. Okay, so now let's talk about this one that Evan suggested. What times itself is -4? Oh, nothing? Because -2 times -2 is +4, right? And it can't be +2 times +2 because that's also 4. So is there anything that is times itself that is -4? So you're telling me that you can't take the square root of -4. Is that what you're telling me? Here's what I'll tell you. You can't take the square root of -4 yet. That's some foreshadowing right there for you. Okay? So for now, we're going to write undefined. Okay? For now, we're going to write undefined. Well, how do I graph something that's undefined? You can't, can you? Okay, so when I go to plot these points, I can only plot the top 4 points. You okay with that? So please go ahead and do that now. 4, 2, 1, 1, 0, 0. Okay, you got it plotted? Can we connect them? How do you know? They came from the equation, right? The x values that we chose, we put them into this equation to get these y values. What do I do this way? Nothing, right? So I don't put an arrow right here? I can't, can I? Okay. X-intercept. 0, 0, very good. Y-intercept? Awesome. Domain. Remember when we're talking about domain, we're talking about our x values. So we say how far to the left and how far to the right. So how far to the left does this go? Oh, to 0. How far to the right does it go? All the way, right? So we're going to have to say everything greater than or equal to 0. It's not all real numbers this time, is it? Okay. So that's inequality notation. What does the interval notation look like? Well, where does it start? 0. And where does it go? Infinity. And what goes around the infinity? Parentheses, right? And what goes around the 0? That's definitely a bracket. Good job. Will we ever put a bracket around the parenthesis? Do you know where the end of infinity is? Yeah, me neither. It's okay. We got a parenthesis around the infinity, always. Okay? What about the range? The range are what values? The y values. So we're talking about how far down it goes and how far up does it go. So how far down does this go? To 0. And how far up does it go? Infinity. So y is greater than or equal to 0. So what's the interval notation look like? So exactly the same as the domain? Awesome. What can we circle? And how do you know it's continuous? No breaks or holes. Okay? What about the maximum? When we're talking about maximum and minimum, what are we looking for? A point, right? A specific point. So what's the maximum point that it gets to? Correct. It doesn't have one. Because it goes to infinity, there's not a maximum point, is there? Okay, what about a minimum point? Oh, this one does have a minimum point, doesn't it? The lowest point it gets to is 0, 0. Intervals of increase. So as I'm moving from the left to the right across the graph, where is it increasing? Yeah, everywhere, right? As soon as it starts, it's increasing and continues increasing the whole time, right? So, what do you think I should put? From 0 to infinity? What goes around the 0? What goes around the infinity? Oh, parentheses. That's exactly right. Why is there not a bracket around the 0? Do we ever put brackets around intervals of increase and decrease? No, because we cannot be increasing or decreasing at a point. So that point cannot be included, but right after it is. Okay? What about intervals of decrease? Yeah, if it's increasing the whole time, does it ever decrease? No. Somebody told me yesterday that my handwriting was too messy to read. And I said, babe, that's not messy, that's cursive. So they were like, oh. And it made me laugh inside my head. Not out loud to their face, but inside my head, I have to be honest, I was laughing a little. Okay. All right, so as x goes to the left, as we're going to the left, where's y going? So as we're going this way, what's happening to the graph? It's going where? Down to where? To 0. As x is going to the right, where's y going? Infinity. It's going all the way up, isn't it? Okay. Any questions on that one? Let's go on to the next one. What's it called? Absolutely. Oops. How about if I spell it correctly? That would be nice, right? Cube root. What else is it called? Radical. It's still called a radical because it still has that symbol, right? The little baby 3 is what tells you it's a cube root as opposed to a square root, right? Okay. So remember, a cube root means, square root means what times itself equals that number, right? So what's a cube root? What times itself is that. So what kind of smart values are we going to choose for our table? 1. Yep.
Miss Kingston.
Yes, ma'am.
Do you have Sarah Lopez?
Yes.
Can you send her to the office?
Yes, I will.
Thank you.
Just hurry. Just hurry if you can. Okay. So what times itself is 1. Okay. Sorry. From here I couldn't see her, and I was like, I don't think so. Oh, but then she was right. And I look over here, and you're like, yeah. So thank you very much for that. I appreciate it. Okay. So what else do we know the cube root of? 0. Excellent. What is the cube root of 0? 0. Okay, what else do we know the cube root of? So 8, right? What's the cube root of 8? 2. Because 2 times 2 times 2 is 8, right? So Evan said, what about negative 1? What times itself is negative 1? Negative 1. We do know the cube root of negative 1, don't we? So what else do we know the cube root of then? Negative 8 for sure. And what is that? Negative 2. Okay, so please go ahead and plot those points on your graph. Can I connect them? How do you know? They came from the function. They came from the equation, right? And remember that it's a curve. It's not a straight line, right? We're not playing dot to dot. Although I didn't really do a great job of hitting that dot right there. Hope you'll forgive me for that. Okay. X-intercept. 0, 0. Y-intercept. 0, 0. Okay, excellent. Domain. How far to the left does it go? How far to the right does it go? So, all real numbers and negative infinity to positive infinity, right? Okay. Range. How far down does it go and how far up does it go? All real numbers. Good. Negative infinity to positive infinity. Now, this one confuses people sometimes. I'll tell you that. I'll be honest with you about that. Okay? Because when I say how far down does it go, it kind of looks like it starts to stop, right? Does it? It does not. As far left as it goes, it keeps going down. Okay? Does that make sense? Continuous or discrete? Continuous. What would make it be discrete? If it had a break or a hole in it, or if it was just a bunch of dots. Right? If all I had was the 5 dots on there that I begin with, because it was only given to me as a table and not an equation, that would definitely be discrete, wouldn't it? Okay? Maximum point? None. Because it goes to infinity, it doesn't stop anywhere to have a maximum. What about minimum? None. Same thing. Now remember, we have done these that had a maximum or a minimum, right? Quadratic had a minimum because it stopped at a point, because its range was different. You remember that? Okay. Intervals of increase and decrease. What do you think? So is that increase or decrease? Why do people get confused on this? They forget to go where? Left to right. That's exactly right. Okay. They forget to go the left to right. They start in the middle and say, oh, that's decreasing and that's increasing. But remember, we don't do that. We start from the left and go to the right. And this whole time, the whole graph is increasing, right? So negative infinity to positive infinity. So where's the decrease? There is none. Correct. So as x's are moving to the left, where's the y going? All the way down, right? So negative infinity. As x's are going to the right, where are the y going? Where are the y's going? All the way up. So positive infinity. Okay. Questions? You good? Now this one looks a little different, and if you'll give me just a second, I'll explain it to you, and I think it will make sense. Okay? This right here is the equation. This second part is a parameter we have to take into account in just a second. Okay? So first of all, what do you think this is called? Good guess. You want a hint? Where is the variable? What's typically the variable? X, right? Where is the variable? It's a little baby number way up high. You guys know what we call those? Exponents. So guess what kind of function this is? Exponential. Now I'm going to leave it exponential for a second. That's not the whole name. We're going to fill it in just a second. Okay? So it's exponential something. If you know it, you be quiet. I'm glad you know it, but you be quiet. Okay? I want everybody to get a chance to see it. Okay? Now, for argument's sake, let's go ahead and choose a value for b so that it's not confusing, so people don't think we have two variables. Because right now b, it tells me what b is, but x is really our only variable here. Okay? So what do you think is the most common value for b that people would choose if I tell you b has to be between 0 and 1? 0.5, right? Or a half. So let's choose y equals 1/2 to the x power. You okay with that? So if I choose y equals 1/2 to the x power, what do you think our smart value is for us to choose for the table? What are two that are always good? Almost always, I should say. 1 and 0, right? So let's go ahead and choose 1 and let's go ahead and choose 0. Now, anything to the first power is just itself, right? So 1/2 to the first power is just 1/2. Now let's see if you remember this rule. If I say 1/2 to the 0 power, what's anything to the 0 power? Absolutely, Jade. That's 1. Okay? We will definitely take some time when we get to exponential functions to explain that, to make sure you understand it, because it's kind of a big deal. Okay? So I'm kind of just passing over it right now, but remember, this is just a general overlook on all of our parent functions right now. Okay, we're going to get into depth for each one of these as we get there. Okay, so now is when it gets kind of hairy, right? 1/2. What's kind of maybe a logical next step? I've got 0, I've got 1, maybe what about 2? Squaring something is usually pretty easy, right? Do I know what 1/2 squared is? Well, what's 1 squared? 1. What's 2 squared? So does it make sense that 1/2 squared would be 1/4? Yes? Okay. So if I choose 2, 1/2 squared is 1/4. And then usually at what other kind of values do I like you to get into the table? Maybe some negative values? So here's where you may need to trust me a little bit. Because if I choose -1 and -2, I need to tell you that 1/2 to the -1 power is 2. And 1/2 to the -2 power is 4. And if you don't know that yet, that's okay. But I do need you to trust me that it's right so that we can go on. Is that fair? Okay, like I told you a minute ago, when we get to exponential functions, when we're studying those in depth, this will make sense. Okay, I can almost promise you that. Almost, because I still don't know your math skills quite yet. Okay, so let's please plot this on the graph. You good? You good? Okay. Awesome. Wait, out of here? Oh, okay, good. Can I connect them? Okay, guys, I need you to understand that this is something I'm not very good at. Okay? I can draw that side really good. This side, if you think about it, if 1 is 1/2 and 2 is 1/4, what's 3 going to be? 1/8, and 4 is going to be 1/16, and then 1/32, and then 1/64. Am I ever going to touch this line? Am I ever going to get to 0? No, but I'm not great at drawing that because I have a marker and I don't have infinite space between my marker and the line. So when you draw it, just be careful. We're definitely not crossing the line, are we? Okay, but just be careful you don't come back up, because it's just getting closer and closer to this line without crossing it. Now, I'm going to go ahead and do a spoiler here. It's not too much of a spoiler because I'm only telling you one thing, not the whole story. Okay? But this function right here is actually getting closer and closer and closer to this axis, but never touching it. And that has a name. And it's one of my favorite math words of all time. Because this axis right here is an asymptote. And I love that word because I misuse it on purpose all the time. Like I say things like, I'm going to kick your asymptote. Because I'm a teacher, and for me to say a sentence that starts like that, you panic because you think I'm going to stop at the beginning of the word, and then I don't, and then you laugh. Because I'm not supposed to say things like that. You know what I'm saying? Now, I'm not going to go into any more depth after that. There's some rules about asymptotes, and we'll get there when we get there, okay? But just know that about me. You know, I told you yesterday that I was a weirdo. There's another example, okay? All right, let's talk about the X-Intercept. Yeah, you're looking at me weird because I literally just said it never crosses the x-axis, right? So where's the X-Intercept? Yeah, it doesn't have one, does it? There's not one. So what about the Y-intercept? 0, 1. So that's different than any of the other examples we've done so far, isn't it? They've always either had an X or a Y-intercept or both, and it was usually the same thing, right? This time it's different, isn't it? Okay. Look at the domain. How far to the left does this go? And how far to the right does it go? So all real numbers, negative infinity to positive infinity. And how far down does it go? Yeah, that's weird, right? Because I said it gets closer and closer to the axis but never touches it, right? So what's it getting really, 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 really close to? 0, but it's never touching 0, right? So it's going to look like this. Y is greater than 0. It's not greater than or equal because it never gets there. It's just greater than 0. That means when I go to write it in interval notation, it's going to look like 0 to infinity, but both sides will have a parenthesis. Does that make sense? Okay. What can I circle? Continuous because has no holes or breaks, right? Okay. Minimum and maximum. What's the maximum point? Correct. There's not one. And where's the minimum point? Correct. There's not one. Where is it increasing? As I move from left to right, where is it increasing? Nowhere. Where is it decreasing? Everywhere. So across the whole domain, it's increasing, or excuse me, it's decreasing. So my whole domain is from negative infinity to positive infinity, right? So as x is going to the left, where is y going? To positive infinity because it's going up, right? As x is going to the right, where is y going? Is it? Is it going all the way down? Where is it going to? It's going to 0, right? Is it ever getting to 0? No. Okay. Now, we have one more thing to fill in, and that's the rest of the name, right? What's happening to these values? You told me a second they're decreasing the whole time, right? So this is not called exponential decrease, although that would make sense. Okay? It's actually called exponential decay. Because across the whole length of the domain, the range is falling. Okay? Any questions about that? So we're going to do something similar on this one. Well, what kind of function is this? What's the name of it? It's exponential, isn't it? Because it's still b to the x power. So it's still exponential. And we will fill in the name in just a minute. If you already know it, please don't shout it out, just like before. Okay? So, what do you want? What kind of smart values do you want to pick for the table? 1 and 0 for sure. So, let's choose an equation. If I need a b value to be greater than 1, what do you think is the most common value people choose? 2. So we're going to say y equals 2 to the x power. Now this one seems a little easier because it's a number you're familiar with and it's not a fraction, because you guys tend to freak out when there's fractions. Okay? So what's 2 to the first power? 2. What's 2 to the 0 power? Because we decided a minute ago that anything to the 0 power was 1, right? Okay? So what other values do you want to choose here? Probably a 2, right? Because 2 squared seems relatively easy, right? That's 4. But then what other kind of values do I like you to choose? Negatives. So if we choose -1 and -2, this may need to be a place that you trust me again, okay, until we can get there and actually talk about it. 2 to the -1 power is 1/2. 2 to the -2 power, any guesses? 1/4. 1/4. Okay. Please plot those points on your graph. Kinda. Yeah, it kinda is. Can I connect them? Yes, why? It's an equation. Again, do your best on this side. I'm trying to do my best on mine. Actually, that's pretty good. I'm getting better at this. It's only taken me 23 years. What's my X-Intercept? There's none, okay. Is it the same kind of thing on this one that it was on this one up here? There's an asymptote right here. Okay. What's my Y-intercept? 0, 1. Okay. What's my domain? How far left does it go and how far right does it go? All the way, right? So all real numbers, -infinity to positive infinity. What's the range? How far down does it go? How far up does it go? Y is greater than 0. So from 0, not including 0, all the way to infinity, right? Now, a second ago he said, oh, so it's basically just the opposite of the one we just did. And I was really careful not to agree with him right away, because are these opposites? Oh, they're exactly the same, aren't they? So really, what is it? It's a reflection, isn't it? Okay, it's a reflection over the y-axis. So some things are going to flip and some things aren't. So just keep that in mind. Okay, domain and range stayed exactly the same, didn't they? Okay, what do I circle? Continuous, good. Maximum? None. Minimum? Intervals of increase. Where is it increasing? Oh, everywhere. So from -infinity to positive infinity, over the whole domain it's increasing, right? Where is the interval of decrease then? There's none. So notice those compared to the one we just did. Those did switch, didn't they? Okay. As x is going to the left, what's happening to y? Where is it going toward? 0. Does it ever get there? No, but that's where it's going toward, right? As x is going to the right, where is y going? To infinity. Any questions? Okay, so here's what we have to finish. What do we have to finish? The name, right? Okay, so if this one was called exponential decay, because from left to right it was decreasing, right? What do you think this one's called if from left to right it is increasing? What do you think it's called? That's exactly right. Exponential growth. Okay? Now, here's what I want us to do. I want us to name the rest of these in this packet. Okay? I want you to know the names of the rest of these in this packet. We are not finishing the rest of this packet today. Okay? But I do want you to have the names written down in this packet. Okay? What do you think this one's called? Well, what does it look like? A fraction. What's another name for a fraction? Ratio. So what if we call this a rational function? Would that make sense? Yeah? Okay. Any questions about that? You know how sometimes I made you guess what these were because you could figure it out? I'm just going to tell you the rest. Is that okay? I don't mean that disrespectfully. You just haven't ever talked about them before. Okay? What does that say? Logarithmic. God bless you. Logarithmic. Got it okay? Okay. Let's go to the last two. Guess what this one's called? Yeah, logarithmic. And guess what the last one's called? Logarithmic. Any questions?